Hello, protocols, packets, and programs. It is the height of summer conference season. If you want to practice threat modeling, play with stochastic models, and enjoy fanciful names, then go play some D&D and other RPGs at Gen Con. It's like Appsec, but fun. Which means this week we talk with Jonathan Schneider about refactoring, rewriting, and rethinking the ways we deal with legacy software. Roll for initiative and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news, it's time for Application Security Weekly. Tired of the endless cycle of cloud vulnerabilities? Avoid over 95% of CVEs with minimal container images from Minimus. No bloated base layers, no unnecessary packages, just what your app needs to run. Drop Minimus images into existing deployments to dramatically reduce your attack surface and remediation work. Maximum security, minimum effort. That's Minimus. Visit securityweekly.com/Minimus to learn more. This is episode 342, recorded August 4th, 2025. I'm your DM for this week, and gathering the party is, as mentioned, Jonathan, who's a founder of Open Rewrite, an open source auto refactoring tool. He was a senior engineer at Gradle and a senior engineering manager at Pivotal. He's the author of 2 books, SRE with Java Microservices, and co-author of Automated Code Remediation. And today, a visitor on our podcast. Hello, Jonathan. Thank you for joining us.
Hi, pleasure to be here.
Now, one of the things that my co-host as well, John Kinsella, he couldn't be here today, but the two of us often have a discussion about refactoring, rewriting. I love rewriting code. I love refactoring code. It's not necessarily always the right thing to do all the time. There are engineering constraints. Sometimes people have to ship product. So before we get into the act of rewriting, could you tell us a little why? Why do we write code? Why do engineers, other than fixing bugs, if the code is running and working, can't we just leave it alone?
That is less true than it's ever been. So I think back to the first part of my career and working on a group health system written in COBOL 35 years earlier. There was nobody that worked on the original system was still employed by the company. It was running on a particular database that had been long since deprecated and IBM was removing. And there just became this sudden fear of what happens if it stops running? Amazingly, there was an indirect person that knew of the people that used to work on it and knew where they sat in the building. And we went and found a filing cabinet that we had to break into, and there were the manuals to this whole system still in this filing cabinet. Some years
written
later.
Manuals, I love it. Yeah.
Written manuals, yeah, big binders, right? And the point is, that system had been running for quite a long time. Interestingly, the more modern the application, the more dependent it is on third-party and open source stuff. That stuff evolves at its own pace. If you don't keep up, your app stops functioning.
Yeah, and I think the subtext of what you're describing too is not so much we just need to keep these, minor version bumps of these dependencies. If you're working on it, you need to understand it, whether you're reading through some paper manuals.
Absolutely.
Or trying to read the code. And that's a key thing. So refactoring is a great way to understand what's going on, as well as we could do better, or maybe make it more understandable, or just make it more readable for other engineers. That's my approach. One of the things now is that, so we've said a little bit of why, and I think that's going to be a theme we'll come back to, but now how, or what is Open Write? So tell us a little bit of that story here, because having any help sounds amazing for when you have to go and refactor or rewrite something.
Yeah, absolutely. The origin story for me on Open Rewrite is back at Netflix about 10 years ago, working on engineering tools team. So a central team inside of the overall platform engineering organization. And to some extent, we were responsible for helping push the organization forward. Think Java 6 to 7 to 8, or trying to kill off an old logging library, trying to fix security vulnerabilities. And yet we could not impose any constraints on what product engineers did because of that special freedom and responsibility culture that that Netflix was so famous for at that time. We started out doing, I think, what typically engineering tools teams do, something like an early internal developer portal, trying to surface to product engineers where they were relative to the objective and provide more context. The idea being, if you provide more context, people will action it, but it just didn't work out that way, right? So it just resulted in approximately zero action. And so desperate, I go to product teams and say, what could I do to help you move forward? And the answer is usually something sarcastically along the lines of, do it for me, otherwise I got something else to do.
There's the big reveal. Yeah.
Yeah. So at some point you start taking that literally, and how do I do it for them? That implies some sort of automation. How do we make sure that's accurate to gain trust in the system?
And what's interesting there to me is that it's not like that was coming from just a pure engineering. We need to move off of major versions.
Absolutely.
Logging. Log4j comes to mind if we're talking about logging in Java.
That's right.
But even Log4j has an aspect of security. So security could kind of mandate and say, thou shalt, you must, you have to do this.
Right.
But you can't wield that stick. You can't tell everybody you have to do this all the time, because security doesn't drive engineering. It doesn't drive products. It should contribute. So what was some of and you described doing the work. How then did you do the work? I assume that you didn't then spend 6 months just reading the code and trying to understand it and then writing something, because you're on your own self-imposed or desired timelines as well.
Right, of course. And at that point, there were 2 or 3 of us on this engineering tools team, and there were 700 other engineers. So obviously, I can't.
Good luck.
I can't deal with their 20,000 repositories or whatever it was at the time. So yeah, you have to somehow find a way of creating a piece of automation that will make the change for them. Probably like most folks, we started out thinking, well, we'll just issue mass PRs, right? And that doesn't tend to go over super well. I like to say now, a PR issued by a central team is like unwelcome advice coming from an in-law. You're just looking for a reason to reject it. It could be great advice. Hey, you can lose a few pounds. Hey, what are you talking about? I got a hard life right now. You're just looking for a reason to be a bit, skeptical of it. And so we actually had to work quite a bit at crafting an experience that was more pull-based rather than push-based. Rather than me pushing a PR to them, I try to surface context to them, but where I'm surfacing that context to them is kind of the easy button, but you can fix it too, right? And that's and if the product team pulls, whether it's through direct commits or PRs to their own code base, it tends to have a much higher rate of success.
Part of that success, I assume, also has to come from you or the team having confidence that this pull isn't going to blow things up.
Absolutely.
So yeah. So how do you gain that confidence that this change, whether large or small, is not going to accidentally cause even more work to fix a cascade of errors or bugs it's suddenly introduced?
Absolutely. There's a huge dose of practicality here is what it comes down to. For those not familiar with Open Rewrite is kind of data, lossless semantic tree. We can talk about that later, but then recipes, which are programs that make an individual change. Now, these programs get assembled into higher and higher orders of, encapsulation. So something like a Spring Boot 3.4 migration at this point has almost 4,000 individual recipes inside of it, like doing this property change, this API change, so on and so forth. And so if you look at a complex recipe like that, to migrate to Spring Boot 3.4, I first have to get to 3.3, which is its own recipe, which means I have to get to 3.2, which means I have to get to 3.1, which means 3.0, which means I have to migrate to Java 17, which means I have to get to 11, which means I have to get to 8. So these things get stacked like this. And so one way people gain confidence is by simply running the sub recipe and getting that to production. Maybe I'll just do a Java 17 migration first, but stay on Spring Boot 2. Then I'll come back later and I'll run the larger recipe. To the extent that one product team has less confidence in their software delivery lifecycle, less automated testing, less whatever the case might be, they are going to be incented to do that recipe fragmentation a little bit more than a team that has a higher degree of confidence. And that's just totally okay, right? So we basically say, I don't expect that a particular change will have the same rate of adoption across every product team. It's going to have slower or faster adoption depending on their confidence in their release process.
And to be clear, too, to get into some of the technical side of things, this is not just a grep and replace or a sed -i where you're saying, oh, this version had used this configuration name.
Absolutely.
And you just change this configuration name. It's you mentioned it's going into the AST. It's understanding the semantics. Yeah. Tell us a little bit about that, because to me, being familiar with it a little bit, that does actually instill some more confidence in me, but it's probably a good idea that we convince our audience too.
Absolutely. So actually, I'm glad you mentioned AST, because to do like compilers 101 here again, we've got the text to code. And the first thing a compiler does is tokenize that, produce an abstract syntax tree, which is really still just the syntax of the code, but it's structural now. It's in a tree form. The next phase is something called type attribution, where the compiler goes back through that tree now and navigates it and tries to assign symbols to all the different places in the tree. So I see this method called receiver logger.info. I need to understand what's the type of logger I'm talking about here. What's the actual type that this method is being called on? Because that's important in many cases to generate the end result. So it's this type attributed abstract syntax tree that Open Rewrite's based on. And indeed, the data that we're operating on will intercept the compiler up to that phase where it's done type attribution and pull all the data out of the compiler. It's a little harder than that, though, because at that point that the compilers reached a type attributed abstract syntax tree, it's usually thrown away all the formatting and comments and things, which it doesn't need anymore, right? It's an intermediate representation going to something else. So we have to reach back and bolt back all that information onto this now intermediate representation, which really is the representation that serves as the foundation of a code change. And I wish I didn't have to do any of this. When I started with Open Rewrite, I looked around at my left and right, and I saw Google had a technology called Refaster, and Uber had Piranha, and Facebook had Code Mods, and each of those were abstract syntax tree based. So they had the syntax structure, but they didn't have the type attribution. And the very first problem I was trying to do is replace an old internal logging library called blitz4j with just a more common open source logging library. And yet the syntax looked almost the same. It'd be logger.info, argument. I couldn't tell just by looking at the abstract syntax tree, was this actually already migrated, or was this still on the old library that I was trying to change? It's a day one problem. Threw me into this like nasty deep end of like having to suck out the type attribution as well.
That's funny. I guess in retrospect, I'll offer up, at least it's better to discover the day one problem on day one rather than Absolutely. Day 100 and have to rewrite and refactor your own code. But the context there is that the AST to AST, you can, I love the idea of transpiling. We can see, Go or Rust turn into WASM. That's wonderful for compilers, for the binary to execute. But that context you mentioned is for us humans, because it's not helpful to just refactor code and then still have no idea how it works, or not have anything readable to the developer to understand it. So with that in mind, and you've given a few light examples, because you give us some more examples of how this gets complex, in addition to even where it, let's start with success, but maybe end on that down note and say, like, where has it either failed or been a bit harder to be helpful?
Right. So some other uses of that kind of deep information, I think about a situation that came out of one of our major insurers a few years ago. They were just trying to identify every REST endpoint defined in their code that produced a particular piece of PII. And this is actually a really hard problem with regular code search, because you see some sort of entity object in many cases. Like, I have this example I use: veterinarians return from a REST endpoint. And if I'm looking for, a social security number or something, well, veterinarians contains a person list, which contains a person, which may have a social security number on it. Just seeing veterinarians as the response time to a REST endpoint doesn't tell you that. The type attribution information, so that information about what does veterinarians mean, what is that type, what are all the other fields on it, what are their types, you can kind of navigate recursively down that data structure looking for whether your target piece of data is there or not. That winds up being essential to even answering that question. We also insert on the LST, and this is the lossless semantic tree, and lossless means the formatting allows you to materialize the tree back to source code without losing the original formatting. Uh, we insert what's called markers, which are just kind of arbitrary bags of data that come from the other parts of the build environment. So when I look at, say, a package.json, and I'm looking at, I don't just see the JSON syntax of the dependencies, but attached to each one of those key value pairs, I'll see the whole transitive dependency closure and where it came from and how the dependencies got resolved. And so that a recipe operating on that tree can look at that marker to inform decision how it should be changed ultimately, or whether it should be changed.
And a lot of these examples are understandably very engineering driven. And we actually haven't even mentioned, we've referred to security, but we haven't mentioned anything security specific, even though I would argue that just having well-maintained code, having updated code that your end user, I keep saying end users, developers are your end users in this case.
Absolutely.
That's why I keep tripping over that.
Yeah.
But while the programmers can understand and basically maintain it, I'm trying to avoid the cliche of tech debt and legacy too much.
Of course.
But that's what we're talking about. And I think there is definitely an AppSec dimension there. But more explicitly, have you seen a refactor that has been done for security reasons? And even addressing that personal information from a REST API gets into privacy, gets into data handling. So there's that's already snuck in some AppSec right there too. What else can you sneak in some AppSec for us in this refactoring?
Absolutely. So recipes are just programs, and I think there's main pillars of use cases. One pillar of use case is certainly migration, or at the language level or library level. One is certainly security vulnerability repair. So those typical OWASP top 10 sort of scans turn into transformational recipes that fix those things rather than just identify them. You think about something like a subfield like software composition analysis and trying to rev dependencies. We try to do that a little more richly than like a Dependabot or Renovate does by also being able to rev transitive dependencies, which is a very difficult problem. Depends on the build tool, how to do that idiomatically. Then there's sort of like SAST auto remediation as well, the typical kind of SonarQube, Veracode findings. We try to really evolve those into transformational recipes. Some more recent examples, and one that's really interesting to me right now is this post-quantum cryptography, or preparing for a post-quantum world, and just going and trying to identify every hard-coded algorithm that winds up flowing into the creation somehow of a cipher that gets used to encrypt some data. Actually, that has stretched us quite a bit because for reasons I can't really fully explain, crypto agility, the sources, like an algorithm, a hard-coded algorithm, flow to different end results to the point where the old model of a taint flow spec being is source Boolean, is sync Boolean doesn't actually suffice. You almost have to say, what taint types does a source match? So that as I watch it flow through a pipeline of multiple cryptographic operations, I winnow the set of still relevant taint types down to maybe an empty set or maybe to a non-empty set by the time I get to. So it's really stretched us to really rethink traditional interfaces around taint flow analysis and pipelining and so forth to accommodate.
Yeah, and there's definitely an appeal to me in hearing that, because if we talk about just the sources and sinks, taint flow analysis, that harkens back to early days of AppSec in the late 90s even, or early 200 or early 2000s.
Not new.
With Perl, but and I saw Perl-based programs doing that. Yeah. And I don't want to have to look at Perl again, but they existed. The reason I'm bringing that up, though, is that we also had TLS 1.0, 1.1 in that era, and it took a long time. PCI, for example, was actually harping on this, upgraded TLS 1.2, but it took at least a decade to have that pervasive. Having seen post-quantum or getting down to TLS 1.3 still seems pretty small. Do you anecdotally, I'm trying to figure out between a wish versus observation, do you see that post-quantum or just adoption of TLS 1.3 will be more accelerated or will come faster than how we got to TLS 1.2?
I think we need tools like this in the end. I think about some of our largest customers have north of 4 or 5 billion lines of source code under management, and usually
Good luck.
tens or hundreds of thousands of repositories. And so you think, what effort have we embarked on that we had to touch a large portion of the code that we got done in 2 years? Like none. So whatever you think of the probability of a sufficiently powerful quantum chip arriving, do you think it's 10 years from now? Even if I believe it's 10 years from now, do I believe I can get this work done in 10 years? Like, I don't know.
Yeah, we'll be lucky if the podcast is still going 10 years from now.
That's
we'll
right.
see.
You won't have to address that.
Yeah, exactly.
You won't have to address that.
One of the things, though, talking about millions of lines of code, one of the things we're not trying to say is take the Linux kernel, which is several million. I'm trying to remember. Was it 20 to 25 million? It's something that
Probably.
order of magnitude. But we're not talking about rewriting from C into Rust or a complete code base from one language to another. I think that would be an obvious. That's just not going to happen. You're not going to automate your way through that. But are there less obvious examples of, this probably isn't going to be a successful rewrite, or here are some reasons that's going to, there's going to be dragons here. Here be dragons. Yeah.
There's an interesting concept that I didn't imagine when we started this company 5 years ago, that it's a concept we generally call tech stack liquidity now, which is trying to move from A to B. And the initial obvious use case is framework migration or language version migration. But the less obvious ones are like, I'm trying to move from Oracle to Postgres, or I'm trying to move from this set of J2EE EJBs to Spring Integration, or I'm trying to move from, more recently, like Broadcom Tanzu with a substantial price increase. I'm trying to move to a different path or different platform. And what that usually entails, sometimes it's language to language. Like, I think Jenkins job DSL to GitHub Actions is a good example, like Groovy DSL to YAML. We've seen that happen a number of times with a series of recipes. But this like business pull on tech stack liquidity is even stronger than migration or modernization activities in many cases, because it's the ability to consolidate your tech stack into a fewer set of vendors, or to quickly rip out a vendor who's not collaborative anymore.
And speaking of vendors, this year, especially last year, AI, all the LLM coding assistants are there. And when you mention recipes, here is a word that's getting co-opted and maybe interpreted differently. Like, is this a MCP recipe? Same with crypto. Wait, did we mean crypto coin or cryptography? The old school version, right? Right. So what I also like about this approach is, we talked about, this is the AST. It's a very deterministic model that says this text turned into this representation, these tokens can turn into, and you modify the tokens. Yes. And there's a very clear beginning, middle, and end, very clear way of testing that.
Yes.
LLMs, of course, we get stochastic. That's my fun word for saying just random dice rolls in the intro. Yeah. Exactly. So is there a place for LLM coding here, or how has that influenced your approach, or what how people do approach rewriting?
Absolutely, yeah. So custom recipes are almost universally a need wherever we scale sufficiently in an organization. They're going to want to take an out of the box recipe. They're going to want to change it. They're going to want to do something entirely different. And so previously, you had to develop the skill of recipe development as almost like a discipline, subdiscipline that you would encourage internally, and then prioritize certain recipes and build them. With the advent, I think, of stronger coding agents, what we're finding now is I can basically give a task like, hey, I'm trying to move from an on-prem to containerized workload. I have to change logging output from files to console, so a Splunk agent can pick it up. What are all the ramifications of that? And you'll see like a Claude code, like writing out a plan of, here's all the recipes I'll develop. Open Rewrite's testing framework, its unit testing framework, is very declarative in nature. You tend to specify like before and after text, a code example before and after a recipe's change. So the model has a very easy time writing those sort of unit tests. It's also very hard for the model to cheat on writing those unit tests because it's very declarative in nature, which means that when it then goes to write the recipe, it works through more iterations to try to get the recipe right. It can't just go simply break the unit test in some trivial way that causes the test to pass,
Yeah.
which they do have the predilection to do. And so we found just massive acceleration in developing net new recipes for use cases that we previously would have put on the backlog. But as you alluded to, once you have that recipe, now you've got a deterministic machine you can use to go stamp that change out everywhere in the organization.
Now, has there also been a byproduct where we're talking about you're moving from your framework A to B, as you put it, or off of this tech debt, what have you? Has there also been an outcome where there's more test cases now, and you just actually have more maturity around this code base? Because that does sound, if so, that sounds pretty compelling. That seems like a secondary but very positive artifact.
Yeah, we did form a relationship with DiffBlue that I think we announced several months ago. And DiffBlue is really like a machine learning, reinforcement learning sort of mechanism to synthesize net new unit tests. And in our case, I think what we like to pitch this as is like, I will synthesize unit tests for portions of code that are weak that I'm also changing as part of some other effort, some migration, some repair. So rather than just kind of shotgun blasting unit tests all over the place, let's try to make it a little bit more targeted. But
so,
yeah, regardless of the unit testing generation mechanism, I think that's the relationship between the two.
Okay. And some of the reason my mind is going to this is that the common areas that I've seen at organizations are how documented is the code. Who is there anyone still around who knows about the code, let alone who knows where those original programmers sat?
Right.
Are there test cases?
Right.
But then there's also, I got to pull this in, we have a monorepo versus microservices. And I've seen both where let's decompose the monorepo into a bunch of microservices and let's go and pull all these microservices back into, exactly. You see where this is going.
Absolutely.
Have you seen, how have you seen the rewrites been? Is there one that's more or less successful? Is this engineering preferences? Any insights you can give us there?
The way that we operate, interestingly, monorepo versus microservices has very little impact on the way we operate inside of a customer. We'll generally take a monorepo and discover in it, unsurprisingly, natural business unit level partitions inside that monorepo. And so we actually wind up partitioning the LST alongside those boundaries, and that tends to be defined by the customer. But so that in the end, we're either operating on the whole, or we're operating on one partition or several partitions at a time. And that's in the end no different than that multi-repository recipe run over a series of microservice repositories.
Part of that too does lead me to what about scaling or size? And the reason I bring this up is we did obligatory mention AI and yay, context windows. And maybe it'll work fine within the context window, but I'm pretty sure that you get 1 million lines of code, probably orders of magnitude less than that, ain't gonna fit.
Yeah.
How does Open Rewrite? Are there other gotchas in the sense of this does scale? What's the story there?
Yeah, the other interesting relationship, I think, that again surprised us, but that Open Rewrite has to LLMs now is once tool function calling came about sometime last year, what we found ourselves with is thousands of tools. But these are all the recipes in the marketplace, some of which are transformational, some of which are search, some of which just emit data and what we call data tables, just rows and columns of data. And if we could find a way to just expose all of those recipes as tools to a model, suddenly you really enrich its capabilities. Because we have thousands of them, well, you can't put thousands of tools into a model directly. You can only have somewhat low hundreds, something like that. say only, but and so we basically exposed a tool that first did a search across the whole recipe marketplace and winnowed down the search space so that a model would select the correct recipe. Recipes themselves have a bunch of description and display name and text on them that was designed to help a human user understand how to use it, but helps a model understand how to use it as well. And so imagine you have pre-serialized lossless semantic trees for a whole business unit. The relationship we've now built is essentially an MCP exposure of these tools to a coding agent. So when I have a coding agent looking at a narrow part of the code and saying, I'm introducing a new piece of functionality, but I want to do so in a way that's idiomatically consistent with the way I do it elsewhere, that elsewhere is satisfied by doing a tool request to a recipe that identifies all those locations deterministically and is able to sort of drop in examples to the coding agent to use to make that change more consistent. So it essentially widens the context without actually having the model use more tokens to widen its context.
No, a smart approach. And once again, it's, I'm hearing a very engineering driven type of approach to all of these problems, which I want to loop back with, like, who's running the tool, or help us just, give us a sense of what is an AppSec, perhaps an AppSec engineering, or call it a security platform engineering team. What's a good way for them to engage an eng team? Like, here's your framework. We're going from A to B. We have a tool, but just to say we have a tool, I'm going to guess isn't always sufficient. So what are the missing parts of the story that are equally important? They're just not as cool technical wise.
Yeah, I do think that there's a sort of, market reality that caused us to actually intentionally avoid AppSec as a story the first several years that we were in operation. That's this shift left narrative. And I think the shift left narrative, unintentionally or not, sort of said to a security leader, you're responsible for identification, you're the lighthouse, you're not responsible for remediation. That's engineering shift left. Put it back on them. And the ugly form of that is you get this tension between the two. AppSec leader says engineering leader is lazy, and engineering leader says you don't understand, and this kind of gets this fight. And so we think if we had started and really pitched to the company and the whole purpose of this technology is AppSec remediation, we'd be trying to talk to two people that don't always agree already and sort of say, you both have to be part of this story. And, it's hard enough to convince one person, let alone two. So, why do that to ourselves? So I think yes. If I could only start on one side or another, after all, if remediation has to be done by engineering, then I have to start with engineering. And if I go to an engineering buyer or leader and say, what are your chief concerns? Like it or not, it's not AppSec in many cases, right? Like it's going to be something else.
Let's be real.
It's going to be a migration thing. And so, we started with those use cases. Now, the applicability of security is obviously there. Where we see it be really successful is when an AppSec leader has a really servant-oriented mindset where, I'm not going to ask you to do something that I'm not willing to provide a solution for. The prototypical person here was Jason Chan, a friend of mine. He used to run security at Netflix. Spent a lot of time with him in the woods, training for ultra running and everything. But he really had that mentality of, if I'm going to ask engineering to make a change, I'm going to provide some form of automation to make it easier for them to onboard. And so I think the most forward-thinking AppSec organizations today are thinking in those ways, is almost like whole-based change for the sake of committing it, but a lot more of the responsibility of the remediation is on the AppSec side than on the engineering side.
Yeah, I love that very much, that servant model, or we will assist you or give you as much of a completion as we can, rather than just fill out this checklist, meet this checklist, do this work that we described that you actually have to execute on. Jonathan, you mentioned ultra running. I'm sure 30 minutes is just a walk in the park for you. I know, right? But sadly, 30 minutes is all we had to have for this conversation. But before I do let you go, talking about constraints and building ASTs, we always like to ask our guests to describe AppSec in 3 words. So Let's hear your take on this.
This is fun.
Oh, I love it. A man with optimism. That's wonderful. And especially
I'll let
with
you
optimism.
choose whether that's sarcastic or not.
There was a good facial expression that
right.
if you're only listening, go and watch the video too. That might give away what Jonathan's opinion there was. But whether there was a period or a question mark at the end, I enjoyed this conversation. Period, Jonathan, and would be interested in listening to more about what you've got developing with you and the team over time. So thank you.
Thank you, Mike.
We're going to take a quick break now and return with news of the week. Ransomware, supply chain attacks, 0 days. Cyber threats don't wait, and neither should your defenses. With Threat Locker, you're not just reacting to threats, you're stopping them before they start. Our Zero Trust endpoint protection locks down your environment with pinpoint control over what's allowed to run and what's not. No guesswork, no blind spots. Just proactive, built-for-now security that keeps your business moving. Want to see how a true default deny strategy works? Head over to securityweekly.com/threatlocker and take the first step towards shutting the door on threats before they even knock. Welcome back to Application Security Weekly. We just talked with Jonathan Schneider about rewriting code through ASTs, recipes, and scaling with relative ease. I'm your host, Mike Shima, and I'm here this week with Will from Trail of Bits. And the reason we have Will is that there's really cool vulnerabilities that are dropping today on Monday, August 4th. This will be going out to Tuesday. But before we get in, I'm going to tease everybody with those CVEs in a second. But Will, you did this research as part. Well, tell us how you got into this research in the first place before we talk about what the CVEs were, because this was kind of funny to me.
Sure, yeah. It was part of the onboarding process at Trail of Bits. So I'm a new engineer on the AI ML team. And part of the onboarding process is, you shadow on audits along with testing out some of the tool sets that we use every day, things like CodeQL and SemGrep and walking through code. So as part of that onboarding process for fun, I ran SemGrep across a number of the AI ML targets for Pwn to own. Really, I wanted to look at some hardened targets and try out a lot of different rule sets. So that's a little bit of the background.
I love that because my onboarding process tends to be, sign this PDF, read through these, engineering docs. That's definitely not as fun as play with some Pwn to own. And even better is a lot of times I'm going to guess you can do research and you kind of butt your head against the wall or you don't necessarily find something. But in this case, you found two really good vulnerabilities. So why don't you tell us about what you found and what the target was and then what you found?
Sure. So the target was NVIDIA Triton Inference server. And the goal from it is it's an inference server for AI ML models. So it's quite a bit of functionality all around that. And it's if you're an NVIDIA customer and using their GPUs, it's a good way to get the most out of the products. Along with, they support a lot of different model backends. So it's a very popular product enterprise customers for AI ML functionality. So I chose that one. Quite interested in inference servers, and I ran SemGrep over it, and I ran our public rule sets. So there's quite a number of rule sets in our handbook. These are all public. There's no private, nothing private to it. And it picked up on a couple vulnerabilities, or I should say opportunities, leads. They weren't vulnerabilities quite at the time. One of them in particular in the way that it was handling memory from HTTP requests. And at first, it didn't look exploitable. It was taking an HTTP request and trying to look ahead to understand how much memory to allocate for that request. But something looked a little fishy about it. And as I thought about it a little more, I was like, what if I transferred this from a single HTTP request that was really large into using HTTP transfer encoding? to try and get the server to allocate more and more memory depending on the chunk that was there. So it was a lot of just digging and, yeah, as you said, bashing your head against the wall. But that one in particular looked kind of funny. So that was one that I really wanted to focus on.
And that one's neat because I was looking at the Triton inference server does have they have the open source code on GitHub, and my understanding it's a big blob of Python and a big blob of C++, and the two of them talk to each other through some IPC and other types of magic. This is in some C++ code, and what's interesting to me here is that it's C++, classic HTTP chunking, but you weren't necessarily just saying these chunks overlap and playing with that. You're just throwing a lot there, but a lot. I want to dig into that, figuring out, is this actually a vuln? Is this exploitable? Because a lot sometimes could be manually, here's 10 chunks, 100 chunks. How many chunks did it take in order to actually break this poor server?
Yeah, so for the default instance, it's about 512,000 chunks. So it's quite a large number. And to get towards that number, it was compiling Triton with debugging symbols enabled. And so as each set of transfer chunks are sent, I can look at the value n, which is how much memory is about to be allocated, and to sort of do it from there. And the napkin math would be each 6-byte chunk creates about 16 bytes on the stack. So it has an amplification effect for each chunk. And so I had a general target I was painting around, and then it was just iterating large amounts until I could actually see a crash and get a seg fault and understand it from there.
One of the reasons that I was appreciating having you on to talk about this is we on the show are always interested in that process of identifying and discovering vulns, and especially both tools and techniques, because there's a lot of human brain thinking, but some assistance. And it sounds like you've got 3 tools I've heard so far: semgrep for helping find it, GDB, just being able to actually inspect, in this case, some C++ code, and a napkin for doing the advanced calculus that you had to cover here. Are there other tools that are part of your go-to toolbox that maybe you didn't have to use as much this time, but that you had maybe on deck just in case that you would use for this type of analysis?
CodeQL is typically in there, so both semgrep and CodeQL. Once it moves more towards the memory exploitation phase, then the different set of tools there. I mean, certainly like Eager can be involved. But usually for me, I'm on the code auditing side, and so it's often just grokking how it's operating to see if I have opportunity to exploit in some other way. Maybe pulling in code through the Python, as you mentioned, going outside of the C++ code and pulling from Python. Like, for instance, chaining an exploit by writing a file and then having it, execute into the file. But in this case, not too much more outside of those 3.
Now, part of this is that we started talking about specifically the Triton inference server, and that's CVE. It's was it 2025-23311, which I guess we don't have a named vuln for this. Did you think about giving this a named vuln just for fun, or do we have to talk about the CVE numbers?
I don't have a name offhand. I wish I had a good one.
We'll see if we can come up with one by the end of the segment. No problem. But part of this is that you have, so there's one CVE, this Triton inference server, the HTTP API, and then there's another CVE 23310 that is against the SageMaker API. Now, is there an appreciable difference in how you found or determined the exploitability of this, or is this both relatively identical in the sense it's your transfer encoding, you figured out about 500,000 chunks through on your napkin, and you were able to exploit it? What was there a big difference in these?
No, it looked like a pretty similar vulnerability code pattern that had just been used in the HTTP server as well as SageMaker. And SageMaker operates very similarly, and it takes HTTP post requests, but in that case uses AWS SageMaker as potentially a backend model, whereas HTTP servers is often the model is either hosted locally or maybe it's within the infrastructure connected to Triton. Those are but very similar code pattern, and same semgrep rule identified it.
That's cool. And part of the reason I was asking about that is that when you see vulnerabilities, well, when if I'm on the receiving end of a bug bounty report, for example, I'm going to hope that, oh, here's the example of what the researcher found, but how many other what else did the researcher miss or just didn't have visibility into, and figure out fundamentally that this code base is problematic, and here's or has architecture issues or something like that. And here's where I want to shift from a little bit of the discovery into the disclosure process. Tell us a little bit about, I guess, let's take that journey just as a researcher. What was the disclosure process like? How did you reach out? How was it received?
It was quite easy through NVIDIA's pcert. So they have a form on their site, and just send it through a Word document with all the details. And they were very easy to work with. We had a 90 plus 30 disclosure period. So they had, 90 days to fix it, and then we'll wait another 30 days to disclose so that the fixes can get out there. And really super receptive. We talked back and forth. They didn't need a whole bunch more. There was full POCs in there. I will say what I quite liked about their patch as well is they not only identified a couple of the routes that I hadn't called out, HTTP routes that were exploitable, but they also added in regression testing to prevent this specific type of two-step process they were doing to appear elsewhere. So really excellent stuff.
That is pretty cool. Yes, they didn't just patch they didn't patch the report. They patched the root cause of it, if you will. So that's a great lesson for everyone. One of the things is about that patch, or about their process, and I don't know how much you were involved on the design and reaction part of it, but here's C++. In the year of 2025, it's easy to say, oh, it should be rewritten in Go, in Rust, in PHP, something that's memory safe code, which all three of those count. JavaScript is memory safe as well. How much do you know how much of the discussion there was in the sense of we're just going to get rid of C++ versus they did better regression testing and some hardening of some additional paths? Any insights there?
No, I know that they have released Dynamo, which is a replacement for Triton, and it came out earlier this year, and that's written in Rust, as mentioned, memory safe. So maybe that is part of the move towards it is less opportunity for foot guns with memory safe vulnerabilities using Rust. Right now, from what I can tell right now, both are being supported, and I'm not sure that what the plan is for that.
Yeah, we'll have to reach out and get someone from NVIDIA to talk about that fixing back end, because it sounds like the breaking is the more fun side of things that you have. Looking at this code base, this was part of your onboarding process, and even for example, if you or other companies are engaged on a consulting process, they tend to be time limited. You've got 2 weeks is a classic time range. Sometimes it can be longer. But looking at some code, there can always be that I feel there's more, or there's a code smell or something like that. Looking at this code, if I were to ask you, what would you target next? Or I want to engage you on that 2-week code review or a month long, what would be your thought process in selecting other attack scenarios or other areas of this particular code base to look at?
There's quite a number of different backends. So you mentioned there's the Python backend, a lot HTTP, gRPC. So there's quite a lot of attack surface from the different protocols. I'm quite interested in the model components, so how they're loading different models. I mean, one of the big feature sets is there's a lot of different, it supports safe tensors, ONNX, a bunch of different model types. And that's going to be another attack surface to itself, right? Are all of those being the way they're loaded in? Is that safe? Are they being processed safely? Is there any, obviously, for example, Pickle is very dangerous, a very common attack surface for AI/ML. But maybe I would say if I was going to dig deeper, it would probably be in those areas, because quite a lot of attack surface. They're very interesting, and we're moving quite fast in the space. So there's always, opportunity there, in my opinion.
No, that's cool. And part of the reason, again, my line of questioning is trying to help others who are our audience who want to get into bug bounty or get into researching, get into that breaking side of things. So I want to ask some kind of maybe basic questions, but you found this vulnerability in C++. You had the bravery of diving into some C++ code with GDB, which can be messy when you get into templated code, speaking from experience. How much of an expert, or let me phrase it this way, how much experience did you have with C++ or even Python going into this just to be able to play around and kind of go from that, there's something maybe wrong here, to at least proving that a vulnerability does exist?
Stronger for the Python side, less so for the C++ side. But the bug, one of the nice things I would say is that even if you don't have experience, SemGrep, at least in my opinion, isolates it down to such a point where you can gain experience in the area. So it's, how, for example, SemGrep was flagging an allocate call as allocate. And you can see in the 2 lines before, what is the input look like to that allocate call? And just going through those methods and being like, okay, what does EV buffer peak do? And how does that go into it? So it doesn't feel deep into experience. I mean, I feel like even failure, at least for me, and for most people, I'm sure, is even failing is a good thing, because you gain that experience of having to hunt it all the way down for a SemGrep find or something. I just have to assume you feel sort of similar.
Yeah, I definitely have landed more on the failing side rather than the finding side. So this is why you're answering all the questions and I'm just asking them. So I appreciate that. What does your future look like next? Obviously, you're on the AI ML team with Trail of Bits. There's going to be an area of focus. But do you have, since you're doing this for fun, do you already have your sights set on another code base, more of this code base? Where should we be following your work right now, if we wanted to look over if we were looking over your shoulder, so to speak?
I do quite like the inference servers. I think they're really interesting, and they're so critical to the operations of AI ML. Everything from training models to, deploying the functionality so that users can make inference calls and can communicate with the models. And then I just find the whole space just incredibly interesting. Everything from multimodal attacks to all of the things that we're seeing going on. It is difficult at the speed at which we're operating to try and keep up with everything. But I think for me, helping isolate it down to inference servers has been fruitful and enjoyable. So
that is pretty cool. It's also a very classic type of AppSec attack. Here we've got the overflow, dumping a bunch of data into an HTTP endpoint. We could pick a decade, and it would be kind of hard to distinguish what decade perhaps we're in there. Is there a particular more AI-specific type of threat that you enjoy discovering, or that you really want to play with, in terms of this is more model-specific, or this is what an LLM is susceptible to? I'm just kind of curious there in terms of some of the more modern and cool forward-looking types of attacks that you're thinking of.
I think multimodal is quite interesting. I also think the reconnaissance process of how does, let's say I'm looking at a SaaS application that uses AI ML, how is what I'm putting in here making it to the model, and in what way, shape, and form, along with what tools does it use? That's always sort of a critical reconnaissance piece. Does this have the ability to write the file system through an LLM? Can I say, through let's say it's a chat instance, write the file system and put XYZ in there. So I think the reconnaissance process is really interesting, and there's a lot of opportunity in there, along with pairing that into chained exploits almost. So if I can write the file system, can I immediately get execution through certain tools related to the LLM, to the inference calls and the setup? So I guess that's another area I find quite interesting as well.
Nice. And you alluded to the Trail of Bits has an engineering handbook or security testing handbook. We'll make sure to throw that into the show notes. And again, you mentioned, semgrep debugger. I threw in that napkin as a joke, perhaps. But in terms of these multimodal types of attacks or this other types of reconnaissance, is there another tool that would be good for, especially since this was all an open source list of tools that we've rattled off so far, other tools that you would recommend other researchers just build their skills around, or that can be helpful for that type of reconnaissance?
For multimodal, I believe Pirate and Garrick, if that's how it's pronounced, I was afraid of the tool calls, are both pretty excellent. Pirate's by Microsoft, and you can build multimodal attacks. So for example, create an image that says prompt injection, and then that gets fed in, or create an audio file that has prompt injection and gets fed in. So I think both of those are pretty interesting. I think there's a lot of just opportunity to write our own, depending on what we're looking at as well. Certainly, I've seen some NVIDIA had some really interesting research recently about multimodal attacks, and there was no tool mentioned in there, but that's the kind of thing where I think it's pretty easy to go into the toolbox and say, hey, I just need to bang this out real quick. It needs to be able to create an image that does the thing. Certainly. Yeah.
So speaking of multimodal, since we have you here on audio and video, you have a chance to create a clip. What would be your prompt injection, your the type of attack that you want to insert into the episode right now? Anything come to mind?
I feel like I need like a banner to fly behind my head, and maybe that'll get processed in. Like it just has the prompt injection. I'm thinking like an airplane with like the banner flying behind it, and that'll get processed through the video.
That's awesome. I love it. Will, I appreciate you taking the time to talk with us, because we have highlighted a lot of the Trail of Bits blog posts in the past. And of course, a shout out to Keith Hoodlet, who was the original host who started off this Application Security Weekly podcast. So obviously friend of the show. Is there anything else that you want to call attention to? Do you have some blog posts or some other research that you want to tease over the next couple of months, Will? Something we should be looking out for?
Trailbits blog has been producing just great stuff from the AI/ML side, so that would be the only other one that I would call out.
Awesome. Well, we're definitely going to keep an eye out for your name on the byline of those blog posts. And also, blog posts are helpful. You just have to write out the tool names. You don't have to pronounce them, because some of those tool names do get pretty funky. But before we let you leave, blog posts can be a couple hundred words. We usually just limit all of our guests to 3 words to describe AppSec. So if I threw over to you, describe AppSec in 3 words, would you be able to come up with a fun response under those constraints?
I'll go with enjoyment. I just think there's so much, so much to look at, so much to learn about, so much to read about and to test, and just always the opportunity to learn something new and try something out.
I love it. And I greatly appreciate someone having the optimism and pushing back against the cynicism of AppSec and everything is bad all the time. So I'm glad you're enjoying it. We very much enjoyed listening to you. And you gave us some great examples and some great insight on the research you did. So thanks again, Will.
Thank you.
Want to say thank you to everyone else for joining us. And please do remember to subscribe. Check out the show notes, share about us on the socials, and speaking of hacking things, check out Dark Star by PowerRob. We'll see you next time on Application Security Weekly.